This conference will now be recorded.
Okay, class. I think we have waited 5 minutes, so it's more than enough. So we'll start the session today. Okay, so we'll have a little recap of what we learned yesterday. So, what can anyone tell me what is impurity, which we studied yesterday?
Foreign matter that is present in our drug.
Correct, foreign matter that is present in the drug. Okay, so where do we find all this information about impurities? Which is the legal document or the official book wherein we find what are the impurities which is present. We did study it yesterday. Can anyone tell me?
The IP.
What is IP? What does IP stand for?
Pharmacopoeia.
Pharmacopoeia.
An Indian
Yes.
pharmacopoeia.
Yes, correct. So depending upon the region or the country where it is used, you have different pharmacopoeia. So examples which I showed you were IP, BP and USP. BP meaning British Pharmacopoeia and USP meaning United States Pharmacopoeia. So now we know what is an impurity and where do we find as to how much of impurities should be present in a drug or not. Okay. So we did just see briefly what are the sources of impurities in pharmaceuticals. Okay, so as you can see, the sources of impurities are either it could be from the raw materials which is used, the method of manufacture, atmospheric contamination, intermediate products in the manufacturing process, manufacturing hazards, storage conditions, and accidental substitution or adulteration. Okay, so we'll go into detail into each one of these source of impurities. So the first one is raw materials employed. Just hold on. Yes, so the first one is the raw materials employed in the manufacturing of the pharmaceutical substance. Now, let me give you a vague example. Now, when you're going to prepare coffee or tea, your starting compound is the tea leaves which you're going to use. You're going to boil them just with water. You're going to add sugar and your final product is black tea. If you want normal tea that is with milk, then you're going to add milk also when you're boiling. Am I right?
Yes, ma'am.
So the same
Yes,
way,
ma'am.
yes. So the same way, when you want your drug, there is something called as raw materials. Raw materials are also called as your starting materials. So the starting materials that you are using, you should be sure that they are also pure in nature and that they don't have impurities in them. Now, if you are going to use a starting material which has impurities in them, you're going to pass on those impurities to your product, which we don't want. Okay, so it is essential to verify the identity of the source of the raw materials. Okay, so naturally, mineral sources, plants, animals, microbes, or sometimes synthesized chemicals are used as the raw materials. So now in nature, minerals rarely occurs in a reasonably pure form, and therefore almost all mixtures of closely related substances occur together. So look at some of the examples here. You can see that barium and magnesium impurities are found in calcium minerals. Okay, the same way magnesium or iron compounds are found in zinc. Okay, so in these two examples, your barium and magnesium are the impurities which are found along with your calcium. The same way, magnesium or iron are the impurities which are found in zinc. So the same way you can see the fifth example, rock salt used for the preparation of sodium chloride is contaminated with small amounts of calcium and magnesium chlorides. Okay, so your product here is sodium chloride. You want it to be as pure as possible, but it is bound to contain a little bit of impurities, and you will know the nature of the impurities which will be present based on what is the raw material that you are using. So now when I gave you the tea example, you know that the final tea should not have any traces of your tea leaves. Now supposing you do find a little bit of blackish things which is floating around, you definitely know that it is tea leaves only, which while straining has just come loose, or it has just fallen into your tea. So you are sure that what is there is your tea leaves. The same way here also, you will have a little bit of an idea as to what is there as an impurity. Okay, is this image clear or is it very blur?
Clear, ma'am.
It is clear, ma'am.
Clear. Okay,
Clear,
so you
ma'am.
can see here. Okay, yeah, thank you. So you can see here there are 3 columns. Okay, the first column is the pharmaceutical preparation, that is what you're going to prepare. Okay, the second column is your raw materials, what you are going to use to prepare. Okay, third column mentions the impurities which is present. Okay, so we already saw the sodium chloride rock salt example. You're going to prepare sodium chloride, that is NaCl, from your rock salt, and you already know that the impurities which are going to be present are magnesium and calcium chloride. Okay, the same way when you are going to prepare bismuth compounds, you're going to use bismuth salts as the raw material, and you already know that it is bound to contain impurities of lead, copper and silver. Okay, so these impurities you have got them from your raw materials which is present in your final compound. So you will have a rough idea as to what you will get as an impurity. Sometimes you may get other impurities as well, that we will see once we look into the other sources of impurities. So this was the first source of impurity, that is from the raw materials which is employed. Okay, so next source of impurity is the method of manufacture, meaning how you are going to manufacture your pharmaceutical preparation. So in this method of manufacture, it may introduce new impurities into the final product arising due to contamination, which can either be due to the reagents which you're going to use, the catalysts or the solvents that you are going to use at various stages of the manufacturing process. Okay, so we'll go one by one. So under this method of manufacture, the first one is reagents that you are going to use in the manufacturing process. So now as you can see here in the example, calcium carbonate is the product